Hi everyone. In the previous recorded lectures, we have talked about factor operations, especially how to do factor summation and factor difference utilizing the parallelogram law and triangle rule to help develop or construct the sketches to help us in the calculation, right? And today we're going to discuss one example problems that demonstrate how we can use those two methods to calculate factor summation and factor difference. However, please remember that last times when I discussed those two methods, we have parallelogram law and triangle rule, and these two methods are really used to sketch, right? The factor summation or factor difference. However, when we try to solve for the magnitude or the directions of the factor summations or factor difference, we still have to apply trigonometry law, such as the Pythagoras theorem, right? Or sines or cosines law. Okay, so let's read the problem together. So in here is a problem related to handbrake. So on the handbrake we apply force F1 1 pound and force F2 2 pound, and in here we have to calculate what is the resultant force factor summation and difference using the parallelogram law and triangle rule. Also determine the directions of the resultant force factors with respect to the horizontal axis. Okay, so in solving engineering problems, it's always a good idea to first sketch what information is given. So in here we know that force F1 is equal to 1 pound, force F2 is equal to 2 pound, right? And then alpha is 30 degree, which is the angle made between force F1, right, and horizontal axis, right? And then beta is 45 degree, which is the angle made between the force F2 and the horizontal axis. Okay, and also in here is the next thing that we have to do is to list it out what is being asked. So in here we have to find what is the resultant force factor summation and what is the resultant force factors difference. Okay, and in here we also have to find what is the direction of the force factor summations with respect to the horizontal axis, and what is the directions of the force factor difference with respect to the horizontal axis. And if we can call the horizontal axis in here as x, then we can label this as x. Okay, and I think it's always a good idea to label x and y in here, although we are not using any Cartesian component of the force to calculate the resultant forces. It's always a good idea to do that. Okay, all right, then let's perform the analysis. And in here I'm trying to redraw the sketch of the force diagram. So I have my y-axis, then I have my x-axis, and this is my origin. Okay, to solve for these problems, it's always a good idea to put the tail of the two force factors together. So I'm going to slide the force factor F1 along its line of action, right? So I'm going to slide it such that the tail is located at the origin. So this is force factor F1, and then also I'm going to draw the force factor F2. And in drawing these force factors, it's always a good idea to try to draw it approximately to scale. And the first thing that I would like to demonstrate in here is how to calculate the factor summations rs and theta as x. Meanwhile, for rd and theta dx, I hope you guys can do it as an example, as an exercise at home, or we can do it together in class. Okay. Oops. Right. So let's start it, and I will use the parallelogram law in here to calculate what is rs and theta as x. Okay. In parallelogram law, the first thing that we have to do is to put the tail of two force vectors together, as what we have learned in the previous recorded lecture. Okay, so we put the tail together, and it's located at O right now, and we draw a line that is parallel to force vector F2, right, and a line that is parallel to force vector F1. Okay, then the resultants of the force vector summations can be drawn by connecting these two intersecting points, and that's basically our RS. Okay, and the angle made between RS and the horizontal axis is theta as x. Okay, since in the problem it's given that this angle is alpha, so that we know that this angle is also alpha, right? And we know that this angle right here is beta. Okay, so that the combinations of these two angles in here is equals to, I mean, this angle right here is the combination of alpha plus beta as well. Okay, so that's the constructions of the using the parallelogram law. And then, as I mentioned earlier, to solve for rs and theta as x in here, we have to either apply the Pythagoras theorem or apply a combination of sines and cosines law. And I would like to demonstrate to you how to use the sine and cosines law first, and then later on I will demonstrate to you how to use Pythagoras theorems to calculate rs and theta as x. Okay, so using the sines and cosines law, okay, so using the sines cosine law, basically the triangle that I'm trying to investigate in here right now is this guy right here. Okay, it's this triangle right here. Do you guys see it? Okay, it's basically that triangle. Okay, and if I can draw the triangle, let me draw the triangle again. So okay, and this is alpha plus beta, and the length in here is f1. This length right there is f2. Okay, and this length right here is rs. All right, so I know this is alpha plus beta, then I know this angle right here is 180 minus alpha plus beta. Okay, and this angle right here, we can call it gamma, where gamma is equal to alpha plus theta as x. Okay, applying the cosines law, we can calculate rs as square root of f1 square plus f2 square minus 2 f1 f2 cosine 180 minus alpha plus beta. Okay, calculating this value, we know what is f1, right? F1 is 1 pound, f2 is 2, f1 is 1, f2 is 2, and then alpha plus beta is 75 degree, right? So in here we can calculate we can calculate rs. Okay, we can calculate rs, and if my calculation is correct, we obtain 2.41 pound. Right, and then to calculate theta as x, first I have to calculate what is gamma using the science law, and afterwards I can calculate theta as x because I already know what is gamma and alpha. Okay, so first applying the science law, I will calculate gamma, which is sine gamma divided by f2 and equals to sine 180 minus alpha plus beta divided by rs. Okay, so basically I'm looking at this angle and this length, this angle and this length. Okay, so I can obtain my gamma, okay, is equals to, if I calculate this properly, my gamma is equal to something right there, and I think it's equal to 51.85 degree. Okay, such that when I try to calculate my theta as x, okay, is equals to gamma minus alpha, I will obtain 21.85 degree because alpha is 30 degree. Okay, all right, and that's how we solve the rs and theta as x using the sine cosine law, utilizing the parallelogram law construction method. Okay, and let me draw a boundary in here, and I would like to show you how we can solve it using the Pythagoras theorem. Okay, so using the Pythagoras theorem, I'm going to zoom in these figures properly such that you can see that this triangle that I draw in red is not a right triangle. Okay, it's not a right triangle, and I know that alpha plus beta is 75 degree, such that I can form another triangle by drawing a perpendicular line from this point to the line of action of f1 right here. Okay, and this is a perpendicular, okay, angle, such that in here right now the right triangle that I observe is basically this one. Okay, do you guys see it? Right, and then actually there are two right triangles. This is the big one, and I would like to draw the small one. I use green color. It's this guy. Okay, so we have two right triangles, the big one and the small one, which will be very helpful when we solve these problems using the Pythagoras theorem. Okay, so let me sketch again. Okay, all right, I think that's large enough, and then we have to sketch the green triangle right now. There you go. Okay, and this is the right triangle right there, and notice that this length in here is f2, right? And if I can put a red portion right here, this is f1, right? And then this, if I can put a blue portion right there, this is rs. Yeah, and then let's see what color we can use again. Let's use a dark green color in here. We can calculate this thing right here, and I think it's better to use a much thicker that dark green color in here, because I know this angle right here is alpha plus beta. The length of this dark green color right here is f2 sine alpha plus beta, right? And then the length of this black color right here is f2 cosine alpha plus beta. Alright, so right now we can calculate Rs by applying the Pythagoras theorem, right? So basically the side that we are looking at right now is this side, right? And then this side, right? And then the combination of these sides right here, right? So let's do that. So Rs is square root of the dark green color is f2 sine alpha plus beta square, okay? And we need larger square root over here, plus the red one, right? f1 plus the black one, f2 cosine alpha plus beta, and these whole things are being squared, right? Okay, and if you perform these calculations, you should obtain the same result, which is 2.41 pound. If not, then something is wrong. Okay. All right, and then we also can calculate this angle right here, which is angle gamma, the same gamma that we use in here, right there. So we can calculate tangent gamma is equals to f2 sine alpha plus beta divided by f1 plus f2 cosine alpha plus beta. Okay, using this you can obtain that gamma should be 51.85 degree, such that, right, theta as x is gamma minus alpha is equal to 21.85 degree, right? So that's it, how you solve the factor summation and factor difference using the sine and cosine law, utilizing the parallelogram law method to construct the sketches. Okay, and I have to say that the most important things when you use the Pythagoras theorems right here is to come out what is the right triangle, which one is the right triangle, right? Which right triangle that you have to use. So that's the challenge, and I hope that you can develop it, that skill to select the which one is the right triangle as you solve more problem. Okay. So the next thing I would like to show you how to perform the calculations using the triangle rule, right? And really, as I mentioned earlier, this parallelogram law and triangle rule is just a method to do the sketching, right? To do the sketch. And so this is x, this is y, and you have force F2, and you have force F1, right? So you are either to put the tail of the force F2 to the head of the force F1, or to put the tail of the force F1 to the head of the force F2. And in here I would like to demonstrate to you, what if I put the tail of force F2 to the head of force F1, right? And then afterwards we can, this is our RS, right? And I can erase the original F2, and basically if you observe this triangle, they are basically the same, right? this triangle right here, which is this is alpha, not alpha, it's actually gamma, and then this angle here is alpha, and this angle here is alpha plus beta, and this angle here is theta sx. Okay, which is, when you observe that triangle, is exactly the same as the triangle that we draw in here. Okay, since the triangle are exactly the same between the one sketching with the sketches by the triangle rule and the parallelogram law in here, so that you can calculate rs and theta sx using following the same process using the sine cosine law or Pythagoras theorems as shown before. Okay, so really the difference between the parallelogram law and triangle rule in here is just a matter of the sketch. For the calculation process, you have to choose whether you would like to use the sines or cosines law, or whether you would like to use the Pythagoras theorem. Okay, I think that's it for these lectures, and we are going to continue with finding components of the forces in the next lecture. Thank you.